Okay, if you are in Math 7, we are working from the Advanced 2 textbook. If you are in Math 8, we're working from the Course 3 textbook. We are doing lesson 3.4, similar triangles. And it can be found on pages 128 and 129. So we're going to be focusing on similar triangles. So let's review congruent and similar. Congruent, same shape, same size. Similar, same shape, different size. And proportional. Okay, so let's talk about similar triangles. When two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. So when two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. An easier way of thinking about this, you need to have two pairs of congruent angles. That's another way of thinking about it. Okay, so what does that mean? Well, we've got one triangle that looks like this, with angle measures of 65, 95, and 20. We have another triangle with measures 65, 95, and 20. These triangles are similar because our interior angles are congruent, then our triangles are similar. They are the same shape, but different sizes. So what does this have to do with math? How does this apply to today's lesson? Good question. Okay, the book's given us two triangles with the measures 50, 75, and X, and another triangle with the measures 75, 50, and Y. And they want to know, are these triangles congruent? Well, we have one pair of congruent angles, and we have a second pair of congruent angles. So as long as we have two pairs of congruent angles, we don't have to worry about that third angle. We have two pairs of congruent angles. Therefore, the triangles are similar. So if we have two pairs of congruent angles, we don't need to worry about that third pair. Okay. So now the book has given us another set of triangles with the measures X, 54, and 63. Then we have another triangle with the measures 63, 63, and y. Well, I can see that we have one pair of congruent angles, but 54, 63, x and y. I need to figure out either x or y. We need to figure out what either x or y is. Okay, I'm going to go with x, and I know that the interior angles of a triangle are equal to 180 degrees. So 54 plus 63 plus x equals 180 degrees. So 117 plus x equals 180 degrees. And this is now a basic algebra problem that you already know how to do. X is equal to 63 degrees. So x is equal to 63 degrees. Look at that. Here is our second congruent angle. So we have two pairs of congruent angles. Therefore, the triangles are similar. Okay, let's do another one. No, not another one. Let's do another one. Okay. So the book's given us this triangle. We have a right angle, an x, and 42 degrees. Then they've given us this triangle. We have a right angle, y, and 38 degrees. Well, I can see that we have one pair of congruent angles. Remember, this box indicates that it's a right angle, which means that it's 90 degrees. So we have one pair of congruent angles. Now, I need to figure out either x or y. It doesn't matter which one. I'm going to go with x. And I know that the interior angles of a triangle are equal to 180 degrees. So 90 plus 42 plus x equals 180 degrees. 132 plus x. And this is a basic algebra problem that you guys know how to do. X is equal to 48 degrees. So x is equal to 48 degrees. Oh, we have a 42 and a 48, a 38. So we do not have two pairs of congruent angles. Therefore, the triangles are not similar. Now, last period, somebody said, well, what about y? What if y is congruent with 42 or 48? Well, let's see. Let's check out y. 90 degrees plus 38 degrees plus y equals 180. So 128 plus y equals 180. This is a basic algebra problem that you already know how to do. Y equals 52 degrees. So nope, we are out of luck. We do not have two pairs of congruent angles. So for triangles to be similar, you have to have two pairs of congruent angles. And sometimes you have to do math to figure out X or Y to determine whether you have two pairs, okay? Now, sometimes, well, actually a lot of times in the book and on a lot of the testing, you're gonna see a problem that looks like this. That's a straight line. It doesn't look very straight, but it is straight. You're gonna see this type of problem a lot. You will see a figure like this with, and they'll give you the leg measures. But you'll see very similar, and you're gonna see this quite often. Now, they wanna know, can you figure out what X is? Well, for us to figure out X, we need to know that the triangles are similar so that we can use proportions, right? How can we prove that these triangles are similar? Well, we have one pair of congruent angles. These are both right angles. They're both 90 degrees. And even though they have not given us angle measurements, I can use the rule of vertical angles. These two angles are vertical angles. And we know that vertical angles are congruent. So we now have our two pairs of congruent angles. And that proves that these triangles are similar. So now that we've proven that these triangles are similar, yes, we can use proportions to figure out X. So I'm going to break these triangles apart so that I can find corresponding parts. So this is the first triangle. Here's my right angle, and here's my vertical angle. Now I'm going to rotate this triangle so that I can find my corresponding parts. So here's this triangle. I rotated it. Here's my right angle. And here is my vertical angle. So now I'm going to use corresponding parts and set up a proportion. So this is my big triangle and my small triangle. I'm going to set up big over small. So the height of the big triangle over the height of the small triangle should be equal to the width of the big triangle over the width of the small triangle. We've now set up our proportion. We're going to cross multiply. And now this is an algebra problem that you know how to solve. I need to isolate my variable. X is equal to 48 feet. So X is equal to 48 feet. And we could figure out what that missing length was. because we proved that we had similar triangles. And if we have similar triangles, then we can use proportions to determine missing lengths. So that's what we're doing today. With triangles, you need to have two pairs of congruent angles to prove that the triangles are similar. And sometimes you have to figure out the missing variable. And then sometimes they don't give us the measure of the angles, but we can still prove that they're similar. Right angles and vertical angles, we can prove that they're similar. Then we have to use the idea of proportions to figure out the missing length. So that's what we're doing today.